Welcome everyone to week number 3 in Science 200. This week is all about how to use scientific sources for your information in order to make a presentation. So last week you learned about how science works, and you did that through a couple of examples. Alexander Fleming, the famous microbiologist, and how his work with Staphylococcus aureus, staph bacteria, and then him seeing an accidental introduction of a fungus, Penicillium notatum, to one of his plates, his petri dishes. He saw that there was an area of inhibition around this fungus or mold where the bacteria couldn't grow. And he decided that was kind of important because that fungus must be making a chemical that is killing off the bacteria in this area. He isolated that chemical and called it penicillin. And that's where his work sort of stopped, because that's what he was interested in. He saw an interesting phenomenon, looked at it, studied it, and solved it. And he isolated this chemical that could be used to kill bacteria. It was through the work of other scientists that this type of chemical was made and produced on a mass scale so that it could be used as a drug, and it was also tested very well before it was used in the population. This was particularly important in World War II because it prevented a lot of deaths. Soldiers who were injured by shrapnel and bullets and that sort of thing, plus who had had surgery, often died from infections. And so penicillin prevented so many deaths in World War II. So it was tremendously important and began the age of antibiotics. You also learned about John Snow, who was important in a cholera outbreak in London in studying the public health of this particular outbreak. And he showed that Vibrio cholerae, the bacteria that causes cholera, were being transmitted through water sources instead of through miasma, which you learned about, which were people considered unhealthy vapors or smells that were in the air. So he determined by using his maps and all of his cases that he found that he trudged door to door to find and mapped out all the different water sources. He determined that the cholera outbreak was being transmitted through water sources. So this was an important moment in public health, and it shows you how science works. Evidence is what we're looking for in order to change our opinions about what is going on and to change our understanding about phenomena that are in the world. So that was last week. This week is all about how to use scientific sources. Now, don't think that you're the only person on earth who looks at a scientific paper and feels kind of squeamish, because that is true for everyone, even scientists in other fields, because if that's my field, then I'm going to be able to understand it. But if it's not my field, I want, I don't understand all of that. So you're going to learn how to read a scientific paper. You're going to learn about the sections of a scientific paper and what each section of the paper is designed to do. The most important section, in my opinion, is the abstract, because it gives you an overall view of what this experiment is about, how it was carried out, what the results were, and what the results mean. So the abstract is terribly important. It gives you an overview of the particular work in that paper. And then if it's interesting to you and it is relevant to your problem or situation, then you read it further, and the SUMO text tells you that the introduction is terribly important because it gives you a lot of background information, and you're not going to have that on your topic. So you need that. You need background information, and also the question is explained to you that's being answered in this particular paper. And then the discussion/conclusion section, that might be two different sections, might be one combined, tells you the importance of the results that were gotten through this experiment, through the data that you see presented in the results section. So that explains the importance of the results. And of course, in the results section, you have graphs and tables which tell you what the scientists found. So there are different parts of a scientific paper, and each one has its own purpose, and you should be aware of that. You're also going to learn why it's important to find a credible source. And so that means you don't read Wikipedia normally to get information from, because that's an open source sort of encyclopedia that anybody can add to. And so you don't know if the information is true or not. So you go to scientific sources. How do you find them? PubMed, P-U-B-M-E-D. PubMed is probably the largest database of scientific papers in the world. And you can go there and search for anything. Another really good source is Google Scholar. So you will find scientific papers in those two places. And of course, you can do that through the Shapiro Library. So you find good, credible sources and relevant. So what does relevant mean? That means it has something to do with your topic that you're interested in. So if you're doing a topic on global warming, you don't want to find out which antibiotic is drug resistant at the moment. You got to find relevant information to your particular topic. And the assignment this week is for you to find 3 good, remember, credible and relevant sources on your topic, and then you're going to evaluate those sources. All right, what else do you have going on? You have discussion board posts this week. You didn't have last week, but you do this week. And remember, those are due. Initial posts due by Thursday night. The 2 response posts due by Sunday night before midnight, each of those days. So your discussion board post should include your biggest challenge for you analyzing a scientific source. And if you don't say something about not understanding scientific jargon, I don't know what, because I mean, it baffles me too if it's not my area. So yeah. There's lots of words that you don't know, lots of terminology, and that is true for every even subset of science that we study. How did you overcome this? How did you figure out how to analyze the scientific source and include at least 2 examples of what you saw as a challenge and how you overcame it? Then in your response post, compare your challenges to that person's challenges. Are they similar? Are they different? So discuss that and share tips for analyzing this type of source. Maybe you're going to have Google open on your phone so you can Google all the terminology. I don't know. We'll see what you come up with, because you're going to have other challenges that maybe I don't have. All right, and last of all, my tip of the week is use what you've learned in the textbook, in your SUMO textbook, to answer the discussion board questions. And that will be important, because you have to look at your sources first before you can decide what your challenges are for analyzing a scientific source. So follow the directions for completing your assignments, and this is part of your directions for this week. You have to do the work in the SUMO textbook first before you can do the discussion board postings. And that is terribly important for from this point forward until the end of your life. You always follow directions, always. Terribly important on the job, everywhere. Okay. Let me know if you need anything this week. Let me know if you have any questions, because I will be glad to answer them at any point in the week. There's my email address, m.sigmon@snhu.edu. I will be glad to answer any questions that you have, and I hope that you have a wonderful week this week.